Fluent API. You know, have you ever seen if you are using C Sharp and or Hibernate in Java or something like that? If you see something like this, maybe dv dot something like this. I'm not talking exactly the same, or maybe query. Maybe I'm just writing some pseudocode. Select star from maybe employees dot where maybe salary is greater than something. Okay, dot maybe limit maybe to 100 dot offset maybe to 20 dot execute. For example, again, I don't know what it is. There is nothing like this, but you could have seen these kind of queries, these kind of calls in many programs. Generally, these kind of calls, we call it as chain of methods or a fluent API. There is a concept called fluent API or a chain of methods. I want to implement a similar thing, something called chain of methods. Okay, for example, I want to write maybe calculator dot maybe add of 100 dot add of 200 dot subtract of 20 maybe dot multiply of maybe 30 dot get. I should get the final result. For example, this is what I want to achieve. These are called chain of methods. How can I do that? Okay, how can I do this? This is my ultimate result. I want something like this in implementation. So for that, I create a interface called iCalc. I create something called add. Add is going to return actually its own interface. Subtract is going to return its own interface, same interface. Multiply is going to return same interface. Divide is going to return same interface, and get is going to get you the final result. This is my interface. See this interface. This is an interface. Now I create a concrete type. Let's say type calc is a type which is called structure, which contains data which is called integer or value, something, data or value, whatever that value. Now I want to implement methods for this calc. These all methods, because it has to satisfy this interface in order to call these methods. Without interface also you can call the methods, but you need to implement this interface. So there is nothing called separately implementing an interface. You just need to implement these methods. So what I do is function C calc of add of number of iCalc. What I do, C dot value plus equal to number. And what I going to return, I return the interface. What would be the interface? C itself would be the interface. When can I return it as an interface? The moment it start implementing all. Why it is showing error here? Because I have not implemented all these methods. So it is showing an error. Let's say I go until I implement all the methods, it shows this error. See, the error is gone because I have implemented all the methods. Let me create a new function new calc. I pass some value, it gonna return new calc object, address of calc of value is v. Fine. Now, if I do this, let's say C1 equal to new calc of maybe 20. Now, the chain of methods, the concept I'm talking about is chain of methods or Fluent API. C1 dot add of maybe 100 dot add of maybe 200 dot subtract of 220 dot multiply of 2 dot divide of maybe 10 dot get, maybe R is the result. So 20 plus 100 plus 2 300 320, 320 minus 220 which is 100, 100 multiplied 2 which is called 200, 200 divided by 2 is 20. R should be somewhere, I think I have to change, yeah, here I have to change the divide. The result is 20. So the same method, this method on iCalc, it is returning an interface object. So what is interface object? C itself is an interface object. How can the calc object itself is an interface? Because it is implementing all the methods of this interface. It is satisfying all the method signatures of this interface, then it itself returned as an interface, which we call it as a Fluent API. Okay, we call it as a Fluent API or chain of methods. Like this, actually, most of the database engines or certain things in many programming languages they implement. Okay, I hope you understand the concept. So, in order to call chain of methods, what I did is I've created an interface called iCalc that contains five method signatures, five definitions, method definitions, but top four, these five first four method definitions, they return the same interface. They return the same interface. So since they return the same interface, okay, you can call the all these four methods again and again and again and again. Even you can call multiply dot two. You can again call multiply of three. You can also call subtract of maybe add here add of 400. Any number of times you can call. So 100 and 200, 220 here with this 20 because it's an initial value. 220 minus, sorry, 320 minus 220, 100, 100 plus 400, 500, 500 into 2, it's a thousand into 3, 3000, 3000 divided by 100, 10 is 300. So the result you got to get it as 300, which we call it as a Fluent API, or we can also call it as a chain of methods. Okay, this is one kind of an implementation. Again, it's a design. It's more of a design aspect. Okay, the moment you start using interfaces means you are thinking more about the design of your application. Okay, it's all about the design aspect of your application. Fine. This is what about this Fluent API. If you are aware of the builder is a design pattern. If you look at the builder pattern is Of course, it's a creational pattern. You create an object ultimately, but you build an object. You build an object. So if you really look at the builder pattern is also somewhat incrementally also you can build. Let's say you draw a rectangle. Okay, that means there is an object called rectangle. Then you add a border, you add a background color, you put a text on that, you add a foreground color, you add a border color. Okay, you put a border type, etc. This that means the same rectangle object incrementally you're building it, which we call it as a builder pattern. Like that. I'm just giving some example. You can implement it like that. Simple thing. Let's say I create a rectangle. I have L and B. I have a border. I have a I'm not drawing it, but I'm just giving some data. And then border color. For example, you have something like this. I want to create an object this way. So I create an interface. I can create a interface. This interface may contain set border. Okay, set border. You put some border. You get I shape. Like that, you can put background color. Set. For example, I just put it only these two. And then okay, I just put it like this. So I implement these two methods over here. A function new rectangle. Okay, assume that I got to create a rectangle with just with L and B initially. I return rectangle. I return rectangle. L is L, B is B. I return rectangle. New rectangle. That's what a rectangle. From here, I create and I implement something, function R is rectangle of set border, set maybe set BG color. I return I shape. So what I do, R dot BG color equal to C. Let me, you can put it as, the names can be anything. It's not necessarily that you have to give the same name. And I return R. You don't need to return as well. You can just set like that. Fine. I just want to return R. The reason it's giving error because there are two definitions in this. Similarly, I call it as a set border. I give some maybe B. Okay. Border is B. You return this. Now you see this. So you are incrementally recreating the object. You see that you are incrementally recreating the object. Let's say function R rectangle display display maybe properties of a rectangle fmt.println length is r.l, breadth I have r.b, and then border r.border maybe background color I get all.bg maybe border color is r.bg color. If I give like this, one more method, I put it as set border. Similarly, I also put it as border color. I put as C, which is of string. I also implement C. Okay. Now, if you look at it, a display is just to know that, right. Now, I say R1 is new rectangle with some values. I go and call R1.display. So this is length is this, breadth is this, border and all the things are empty and then zero because zero values are given. Initially there is nothing. But when I say R1 dot border equal to maybe 10, odd one dot set border equal to 10. Okay. Say R1 dot BG set BG color equal to maybe red, maybe. Now you call R1 dot display. You see that this is, I think both the names are given. The reason is border color. I might have given, yeah, both I gave same. So now when I call this, you see that the object is same, but it got built with a new properties. It got built with a new properties by invoking that. Let's say I want to get a new object. I want to get a new object after adding this. It's the same object. It's all these things are applying on the same object. After doing this, I want to get a new object. Let's say R1 dot set border color, maybe green. It gets the same color on R1, but it returns an interface. It returns an interface. So I just take R2, which is an interface basically. This is an interface, but I can type assert it to rectangle. So a new rectangle object, I get it. You don't need to do this because everything is getting applied on R1 only. But since you are returning an interface at any point of time, you can get exactly that particular object. So you can call R2.display. You get the details. This is something kind of a builder pattern. With interfaces I use, but without interfaces also you can do because you are returning, you are incrementally implementing the object. You're incrementally implementing. Incrementally means based on your requirement. Because I want rectangle. Later on, I thought, okay, I should give a border. I should give a color. I should give a background color. I should give a border color. So gradually, incrementally, you are building the object. Should you really use interfaces and all? It depends on. But this is how incrementally you can build the object, which we call it as a builder pattern. So, so technically, you can also call like this. You can also call like this. R1 dot bg color maybe of orange dot. Okay, you can see that. Uh, sorry, dot set border of maybe something, maybe 2 dot set border color of maybe some color. It's some color. It could be maybe blue. The same object getting updated. Let me, instead of R1, let's talk about a new rect of, you get a new rect actually. I'm creating a new object, nothing to do with this. Now I say R3, but R3 is an interface. But I want to get the exact object, so I can type asserted and get the R3, which is a rectangle. So R3 dot display, it got to display actually a new object which is called R3 with all the things. This is called builder pattern. Builder is a design pattern. Earlier we have seen dependency injection for with interfaces. Then we saw fluent API or chain of methods. This one is called a builder pattern. How you got to build an object. Uh, okay, incrementally or with the through separate methods. The same object is getting impacted. Okay, and like this you can call and then get a concrete object as well by type asserting it in Golang. But with the display, you cannot type assert because display is not going to return anything. If you look at display is not even a part of the interface. Display is a method on rectangle. You can call display only on rectangle, not on interface object. So I call display like this after getting the rectangle object. Okay. This is what actually the interface is. How do you use chain of methods or fluent API or builder pattern by using interfaces?